Okay, so good morning, everyone. Today I'm going to discuss about my work, which is Vikriti-ID. It is a novel approach for real-looking fingerprint generation. So myself, Rishabh Shukla, and my co-authors are Dr. Kaur, Aditya, and Vansh. So these are some outline which we are going to discuss today. So what is the introduction of the work, like what we are doing here? So as you know, biometric have a very high impact in our daily life. We use it everywhere from access control to introductions to unlock our phones and some other applications also there for biometrics. However, when we are going for biometrics, we know whenever we want to develop something, we need data. But in the case of biometrics, we don't have much data for that. So this is a big problem for the research community. So as you know, there are five types of fingerprint, like arc, left loop, right loop, pentatrack, and hole. So what we did here, we tried to overcome this limitation by proposing our work with ID, which is a GAN module to generate realistic, unique IDs. I mean, unique fingerprints with some different type of impressions. So we also tested our model by training a deep neural network to test if it is usable in real life or not, and we got a good result. So our generated data set also contain intra-class properties. Means if a impression having a same unique ID, then it must be matched. It will have a good high score while matching, and if they belong to different unique IDs, then the impressions should not give a high score when we are matching them. So we generated 10 impressions for each in our work, and we can increase this number also, and we can decrease it also. It is on us. Whatever you want, we can do it here. It is a festival model. So as you can see here in the figure 2, we have some type of samples. So the first row and the second row, the first row contains 4 impressions of a same unique ID. The second row contains 4 impressions of different unique IDs. So yeah, these are some impressions of our model. So there is some recent work also done in this field. It is not a type of some like any other work is not there, but we have some work already in this field. So we can divide in 2 classes. Basically, the first is some handmade method or some basic technique method, or the second one is some learning based method. So in the first class, we have method like where Gobar filter or Samaya mapper models are used. But here the work lack of some visual clarity in the generated images. And in learning based method, it is good, but it doesn't focus on class specific details of the generated image. Yeah. So these are some recent work we have completed. We can see. So what is the motivation of this work? Why we have go for this approach, and what is the problem basically? So as we know that there is a basic need of a data set for the fingerprint. So we can really focus on that, and it generated class-wise fingerprint images. So we can use it to directly, like we can append any model with this Vikriti-ID, and the Vikriti-ID will generate the data provided to the model for training. So we don't need some type of storage and other things here. So that is also a good thing for us. Also, we have multiple impression generation, so we can generate multiple impression for this, and here the Vikriti-ID overcome this problem of lack of data set. So our proposed approach can be divided in some type of parts. So first of all, what we did, I think it is good if I show you some type of figure, so it will better to understand for you. So in figure 3, you can see here what we have. We first of all we have to feed a noise matrix to the West autoencoder, where the VAE, I mean that variational autoencoder, will generate some type of unique template, which is basically a fingerprint template, but not actual fingerprint. It's just a intermediate image we can see. So this template is fed to a generator, which we already trained that generator will generate some master print there. And this domain key 1, key 2, key 3, key 4, key 5 are deciding factor of the class. If we give it a key 1 with the unique template, then the generated template from this first generator will be a class arc type of fingerprint. If we give it key 2, then the master print will be a class left loop type of fingerprint. So this is the reason of using this module here. And whatever we get in the master print, we will feed it to another generator, which will generate some other impressions of the same fingerprint. It doesn't change anything in the fingerprint. It just generate an impression of that. So for that also we have 5 or 6 or 10. Here we use in our work 10 impressions, but we can increase it in the different keys. So when we give it key 1, the impression is different. When we give it key 2, that it is different. When we give it key 3, the impression is different. So this is the basic work we have done here. Okay, so how we evaluate our work that is performing well. So as you can see in the figure 4, we have some ROC and DBT curves. So here what we did, we compared our work. I mean, whatever data we generated with our Vikriti-ID, we compare it with other publicly available data set. As you can see here, we use FVC and SOCOFing for that. We also check for data leakage. We also check for usability of the model by training some other model with the data set generated by the Vikriti-ID. So you can see here the model is performing well as compared to other data set available in the research community. In the given table, table 1, we can see there are some ERA ADUC score is given for Vikriti-ID and a SOCOFing and a data set. We also tested for data leakage and trained on data set. So we can see here that model is performing well as compared to other data set. And in data leakage, where data leakage sometime when we train a model with some type of data set, then what we get, we will the model, the data set we generate is having some type of leakage for the data set. So which is not here. And we also take positivity. Yeah, these are 3 top points which I discussed earlier, that legal data, usability, and imposter distribution. So these are some imposter distribution graph of the Vikriti-ID and other datasets. So you can see here, they are different and the Vikriti-ID performing well as compared to other datasets. These are some samples generated by Vikriti-ID. So you can see here the first row is arc, then we have left loop, right loop, T arc, and pole. So these are some type of impression we can generate from this. So what is the conclusion for this? So basically, we have developed a model which can generate different type of impressions for this. And we have also trained a deep network for this, where we got a E and AUC in a good number. And in the future, we will try to make our model to be operate our attack and also generate some more type of impressions here. So we'll try in the future work. And these are some references which I already discussed with you. And thank you so much. Any question? Thanks.